Hi friends, I'm back with a new video. Alright, today's video is talking about the tracing the path of ray of light passing through a glass lamp and also determining the refractive index of the glass slab. So you must be wondering, what is glass slab? This is glass slab, okay, which is also known as glass block. I will be finding out, suppose I keep it here. So there will be a ray of light which is passing here, and then it passes through the glass slab and then comes out. So I'll be showing you the ray of light which is actually passing through. We say that when a ray of light goes from one medium to another, it bends, right? So I'll show you that bending, that's the determining the tracing the path of ray of light. All right, and the second is I'll find it refractive index of the glass slab. That can be done either by a formula called Snell's law, that's sin I upon sin R, or the knowing the speed of the two different medium, that the light speed in two different medium, and dividing by that. So I'll be using Snell's law, that is sin I upon sin R. So I'll be utilizing that. So that way we'll find the refractive index of the glass slab by using the formula Snell's law, which says, okay, sin I divided by sin R. This will give you a refractive index, which is also known as N. Some people call it as eta. This is also called eta, right? So we'll be talking about this, and since it is a glass slab, this has to come as 1.5. Let's see how much we are able to come close to this number 1.5. Okay, right, so let's begin with this experiment. Right, for that I have a glass slab here, which I keep it in the center of this paper. Now after keeping in the center of the paper, what do I need to do? First is I'm supposed to take the outline. Okay, I'm supposed to trace the boundary of this glass slab, right? Let's do that. So I trace the boundary. So I have traced the boundary of this glass slab. All right, yeah, so which I can name it as A, B, C and D. This is the name of this glass slab, right? What do I do is I select one point here, okay, where I'm going to draw normal. Okay, so suppose I select here this point. I select this point, and this point I draw normal. To draw normal, what I need to do is I need to take protractor, which I keep it here onto this line, and the point which you have selected, that point you mark this 90 degree. Okay, to be there on a safer side, what I do is I put the 90 degree marking on the below also. So like my line is straight, no point of a time the line is crooked, or it is you can say bend. So this is my points. Now I can join these 2 points. You have to be very careful when you're joining the 2 points, right? So I have joined. This is my normal, okay, which I call it as n dash. So I name it as normal so that you know it. So it's normal. All right, now what I'm supposed to do is nothing but from this point, all right, I will take 30 degree, 40 degree, 45 degree, whichever angle you want, right? Whichever angle you want. People just go for 30, 45, 60 because that's the number is a little easier for us to calculate, right? So people go for those, but you're free to take any angle over here, because ultimately you are doing the experiment. Okay, it's not the sake of calculation. Yeah, so we can take any angle. So for calculation sake, I'm also taking 30 degree only, but I'm saying here you can take 30, 20, whatever the angle you wish to take, you can take it, right? So what we'll do is we'll keep protractor here. Okay, so I keep my protractor here on this 90-degree line, and then I'll see 80, 70, 60. So I'll just mark the 69 here. So the 69. Okay, now what I'm going to do is nothing but I'm going to join this 60 with the help of this. Okay, so I've joined this. uh, this will be, this is your angle, which is angle of incidence. This will be angle of incident, and which is 30 degree. 30 degree. So this is your angle of incident, which is going to be 30 degree, and I put an arrow here. That's very important because each ray will be associated with the arrow mark. So this is nothing but, all right, so this is it. Now what we're supposed to do is nothing but, here is we will place this block back, or this glass slab back to this position here. Okay, so we're keeping it back to this position. After keeping it back to this position, okay, what we are going to do is, all right, so what we'll do is nothing but, now we'll take pens like this here. Okay, what we'll do is nothing but we'll take out the two different color pins. So here I'm going to put it one, and then I'm going to put it on this. So these two pins are on one line here. So if you look at this here, you will find that these two pins are in one line, right? Okay, now what we have to do is nothing but, here is we have to take two more pins, right? And we'll start placing these two pins. All right, now what I'll show you is the two pins which I have here. Okay, this one. Okay, I'm going to look through the glass slab. When I look through the glass slab, and I'm going to show you that they are in one line. So right now you can see that they are not in one line. But if I adjust my camera a bit, you will see that yes, these two pins are, seems to be in one line. How do I know that my pins are in one line? That I will be able to see only one pin. The pin which is there behind that pin won't be able to see. So that means that the pins are in one line. Now what I'm going to do is I'm going to place two more pins which is going to be on this side, right? So I'm going to place the two pins in such a way that all the four pins will be in one line. So let's start doing that. So I just myself, no, they're not in one line. No, no, no. But yeah, if I place it here, okay, if I place it here, okay, I'll find that, okay, uh, okay, this is in line with the other two pins, right? I placed one more, okay, in such a way that, okay, I will see that key, this pin is in line with all the other three pins. So if I place it here, you can see that I can't see the other three pins. It means that the three pins which are there behind the pin. So I place it here. It means that all the four pins are in one line because I can see only the first pin. Look at this here. You can see the two pins here, this two pins and that two pins. But here you can see only one pin. Means that all four pins are collinear. Means they are in one line. So that four pins are in one line right now. Right? So when I say four pins are in one line, means you are able to see only the first pin, this pin. All right, the other pins which are there, you will not be able to see them. So only the first pin is seen. I mean, this is basically this, right? All right, so let us continue now. Next, okay, now what I'll do is I will remove each pin. So I remove this pin, and I circle this point. I remove this pin, I circle this point. I remove this, I don't need anymore now. I remove this and immediately circle the point where I have put the pin. Be very careful because it might happen that you may get too many points are there, but it is very important for you to put the right point. So this is the points which I have. So I name it as P1, let's say. This is P2, then this is P3, and this is the point P4. Okay, what I do is I am going to join the point P3 and P4. So let us join the point P3 and P4. Okay, be very careful, put the points little beside this ruler and then draw a line passing through those points. So this is the point where this is meeting. Okay, what we'll do is this point also we will draw a normal, right? So what I do is I keep my protractor here at this point, and I put this as 90 here. I can take it as I told you that I always do that. I put the 90-degree point on both the sides because I don't want to take any I don't want to avoid any error. So like by doing this I can minimize my error. Okay, so I join these 2 points. And this is proper, this is also proper. A little bit here this side, yeah, so that you get to know the exact point. See how I guessed it right? There is some problem. Now I'm getting my point right. So that is why I always advise to minimize the error. You should do this. So I'm drawing my normal at this point. So this is my normal. Let's say I name it as M and M dash. So this is my normal. I name this as normal again. This is my normal. What I do is this point which I took it as P and this point which I take it as Q. Okay, what I'm going to do is I'm going to join them, right? Let's say this is beginning is going to be P. This I correct myself and I put it as Q. This let's say it is R. I change this as R, and here in the end I put it as S. So I need to put an arrow which I've already put it at the end. So I join this point Q and R. Look at this line QR. I put an arrow is my expected ray. QR is the line which I wrote my here, tracing the path of ray of light passing through the glass slab. So here QR is the line which is actually passing through the glass slab. So we say no, when a ray of light goes from one medium to another it bends. Yes, look at this here, the ray of light is going from rarer medium, that is air. When it goes to the glass, you can see that it is bending. So my students, as I told you that My first aim is what? Tracing the path of ray of light passing through a glass slab. So which is the ray of light which is passing the glass slab is QR. So I'll say the ray QR, ray QR is the tracing the path of ray of light. So the ray of light which is passing through the glass slab is QR. So that was my first aim, and which also says that when a ray of light goes from rarer medium, that's from air, that is PQ, so it is going to the glass slab, it is bending. You can see that it is not a straight line. I'll show you what is the straight line over here. Suppose PQ wants to go straight, how will it go? Check it out. If PQ wants to go straight, if PQ would have gone straight, it would have gone like this. Okay, this is the path it would have followed. So this is the path, and this shift which is out there is, okay, this shift is called as lateral displacement, is called lateral displacement. Okay, so from the main, what is the shift which has taken place is called lateral displacement. So now let's name all the rays here. Okay, so I start with the first ray, this PQ is called as incident ray. It's called incident ray. Okay, then the next one is this. Okay, um, QR is called refracted ray, and the third one and the last one is this one, that is RS, which is called emergent ray. At the same time, we got three angles. Look at here, this one. Okay, the first angle which is called I. Can you see that I? This is I. I is 30 degree, which we had selected, and this is called angle of incidence. Angle of incidence. Okay, here is we have one more angle. Here is, okay, that is normal, and the refracted ray makes an angle called small r, which I'm going to show, and this angle is known as, this angle is known as angle of refraction. Angle of refraction. And the last one, this one, okay, that is the normal and the emergent ray, which makes an angle E. So this angle, this is called angle of emergence. Point to be noted. When it is angle, it's called emergence. When it is ray, it's called emergent. Point to be noted. Here is emergent, and here when it is angle, it is called emergence. Okay, so that's what. And here also, when the ray is there, it's called refracted ray. When angle is there, it's called angle of refraction. Similarly, it is called incidence, angle of incidence, but when it is ray, it's called incident. So those terminologies need to be very, very clear. Now, what is my final thing is nothing but I already have angle of I as 30 degree. So by this, here I write on angle of incidence is equals to 30 degree. Okay, so here I'm going to measure angle of E, which should be again 30, and also I'm going to measure the angle of R, which should be less than 30 degree. Okay, that is INE. It should be less than. So let's measure that. So I keep my protractor here at this point. Please check it out. So I keep my protractor here. So I look at this exactly. You can find this as 30. This is coinciding with exact 30. Okay, so this angle of emergence is 30 degree for us. Okay, now our last thing is we have to measure the angle of refraction. Okay, this is very important. Now let us see what is the angle of refraction comes out to be. Okay, because this will decide your the refractive index of this glass slab. Okay, uh, yes, so let's go for it. Okay, fine. Here I find the angle of refraction as 20 degree. 20 degree. Okay, which I believe that it is little more from my expectation, because I expected this to be 19. Okay, which is 1 degree more. So let us see what is the value we calculate. Okay, so if it is 20, definitely our refractive index is going to be a little problematic. Okay, so let us see the values. Okay, so we have the sine I upon sine R. Here is the refractive index is equals to sine A upon sine R. So it is sine 30 degree divided by sine 20 degree. Let's see what is the value. We'll see the values here. We have got sine. So sine 30 then divided by again sine 20 I equals to, look at this, the value comes out to be 1.46. So if it is 1 if it is 1.46, so this I can round it to number 1.5. Actually the refractive index of the glass slab is 1.5 and my number is very close to this. It's not higher, but it's very close to, because I can round due to the 6, I can round it to the next number, that is become 1.5. So I'm very close to my refractive index is 1.5. So I finished by the second experiment, or the second part of this experiment. It will have no unit because this is the ratio of the same thing, so it will not have any unit. So refractive index has no unit. So look at this. This is the second part of the experiment, which says that determining the refractive index of the glass slab. So with the formula sin I upon sin R, which is denoted as N. So here is the formula. Now I got the values as I is 30, E is 30. So I is always equals to E, and R is always less than 30, that is I and E, so which we got it as 20. So I use the formula N is sin I upon sin R, which is also called Snell's law, which is also called as Snell's law. It was given by a scientist named Snell's law. So sine 30 upon sine 20, which comes as 1.46, I showed you in calculator, and which I can write it definitely as 1 point, because this value is very near to 1.5. So my refractive index value is 1.5, and of course this has no unit because it's the ratio of the same quantity. Thank you so much. Subscribe my video, and click the bell so that you can get the next video very soon. Thank you.